তাহলে আজ আমরা পারমুটেশন এবং কম্বিনেশন এগুলোর ডেফিনেশন, এদের মধ্যে পার্থক্য, এইগুলো জানব। তা পারমুটেশন একবার দেখ, একটা এক্সাম্পল নিই। এ বি সি তিনটে আমরা এলিমেন্টস নিলাম, দিয়ে একটা করে নিয়ে আমরা অ্যারেঞ্জমেন্ট করব। তাহলে এ হতে পারে, বি হতে পারে, সি হতে পারে। অ্যারেঞ্জমেন্টস সাজাবো। যদি দুটো করে নিই তাহলে কি হবে কেউ বলতে পারবি? দেখ, এ বি হবে, বি সি হবে, সি এ হবে। আর কিছু হবে রে? হ্যালো, ব্যাস সাজানোর ক্ষেত্রে একবারে দেখ, যারা সাজানোর ক্ষেত্রে এ বি আর বি এটা দেখ আলাদা, সেই জন্যে ঠিকই বলেছিস, এখানে বি এ হবে, এখানে সি বি হবে, এখানে সি এ হবে। তাহলে দুটো দুটো করে নিয়ে ছখানা হবে। এ বি এ সি হবে। গুড। তিনটে করে নিয়ে হবে, এ কে ফিক্স করলাম বি সি, এ কে ফিক্স করলাম সি বি, বি কে ফিক্স করলাম সি এ সি, বি কে ফিক্স করলাম সি এ, সি কে ফিক্স করলাম এ বি, সি কে ফিক্স করলাম বি এ। এইবারে অন্য যদি আমরা নিতে চাই, দেখবি এর সাথে মিশে যাবে, এদের সাথে মিশে যাবে, আর কিন্তু কিছু হবে না। এই যে এক একটা সজ্জা, এক একটা অ্যারেঞ্জমেন্টস, দেখ তিনটে করে নিয়ে এই একটা, এই একটা, এই একটা, এই অ্যারেঞ্জমেন্টকে আমরা বলি পারমুটেশন। তাহলে অ্যারেঞ্জমেন্টস, পারমুটেশনের ডেফিনেশন মিনিমাম যেন এইটুকু আমরা বলতে পারি, পারমুটেশন ইজ অ্যারেঞ্জমেন্টস অফ নাম্বার। তাহলে পারমুটেশন কি? অ্যারেঞ্জমেন্টস। তোরা ডেফিনেশনে এইটুকু যেন মিনিমাম বলতে পারিস। তাহলে কি বলতো ডেফিনেশন? এদিকে শোন, ইচ অফ different arrangements by taking some out of several things is called permutation. Each of different arrangements, এই লাইনটা যেন থাকে, arrangements by taking some. That out of three things you can take one at a time, out of three things you can take two at a time. সেই জন্য বলছে by some, or all taking three things at a time, out of three taking three at a time. So each of different arrangements made by taking some or all out of several things. Some, S-O-M-E, some. You can take one at a time, two at a time. This is some. Out of three things, you can take three at a time. So all. Each of different arrangements made by taking some or all at a time out of several things is called permutation. So look, in case of permutation, order is important thing. A, B and B A are different. So in case of permutation, order is the most important thing. important thing. That is, AB and BA are different. But you learn later that in case of combination, order does not matter. For example, we have already taken example. For example, permutation of three things, taking two at a time are, look, AB, BA, BC, CB, AC, CA. So, AB and BA are not same because it is arrangements. So, definition, this is definition. In each of different arrangements made by taking some or all at a time out of several things is called permutation. In case of permutation, order does not matter. Order is the most important thing in case of permutation. Then you give an example. So minimum you have to say what is permutation. These are not important for exam, but you are studying permutation. So what is permutation? You should know. Permutation is number of arrangements. You say at least this. Permutation holo sajja sankha. Arrangements. Clear? Hello? Yes, combination. ABC are three things. Now we will make group or selection. So out of three things, we make a group taking one at a time. So in this group, A or B or C. So taking one at a time, you are getting A or B or C. Taking two at a time in a group, AB, BC, CA. But you cannot take BA because AB and BA are same. So you are getting only three groups. So taking three at a time, anyone, how many groups we are getting?
Sir, one, ABC.
ABC, only one group, because in this case order does not matter. So definition, each of different arrangements, this is replaced by selections or groups made by taking some or all out of several things is called combination. Is called combination. So this is definition. What is combination? Combination is selection or groups by taking some or all at a time. So in case of combination, order does not matter. Because AB and B are same. This is difference. For example, combination of three different things taking two at a time are AB, BA and AB, BC and CA. So we are getting only 3, but in case of permutation it is of 6. So what is difference between permutation and combination? Look, so you give first definition. Permutation is number of arrangements. What is combination? Combination is number of selections. In case of permutation, order is the most important thing. In case of combination, order does not matter. Order does not matter. And you give an example, permutation of 3 things, A, B, C, taking 2 at a time, A, B, B, C, C, A and B, A, C, B, A, C. Reverse order also. But in case of combination of 3 things taking 2 at a time are A, B, B, C, C, A. So this is difference between permutation and combination. Fundamental principle of counting. Fundamental principle of counting. Fundamental principle of counting. FPC, most important for permutation and combination. So suppose there are 3 places A, B and C, and suppose you can go from A to B by 3 different ways. This is 1, this is 2, this is 3. And from B to C, you can reach from B to C by 4 possible ways. You know, there are different paths to go from one place to another place. Now my question is, in how many ways I can reach from A to C? From A to C. So look, from A to B, you can go from way number 1. Then from B to C by 1, 2, 3, 4. How many ways? 4 ways. Now if we go from A to B by way number 2, then from B to C by 1, 2, 3 or 4. 4 ways. And if we go from A to B by way number 3, then we reach from B to C by 1, 2, 3, 4. 4 ways. So what are the possible ways? 12. Possible ways, this is 12. So what is our fundamental principle? This is an example. So if an operation can be performed in M ways and another operation can be performed in N ways, so total operation can be performed in M into N ways. So this is fundamental principle. If there are, suppose first one is M, second one is N, suppose C to D is R, then M into N into R. This principle is true for any finite number of operations. So fundamental principle. So what is fundamental principle? So if an operation can be performed in m ways. M ways. And another operation can be performed in n ways, then total operation can be performed in m into n ways. This principle is known as FPC, Fundamental Principle of Counting. So this is true for any finite number of operations. That is, it is 2 for 3, it is 3 for 4, m into n into p, then mnp, and so on. Now we will solve some problem using fundamental principle FPC. So write problem number 1. In how many ways? So write a coin is tossed 3 times. Find total number of possible outcomes. Find total number of possible outcomes. Look, if a coin is tossed, you know either head or tail appear. So if a coin is tossed, you are getting 2 outcomes. So for the first toss, number of possible outcomes equals to 2. What are the outcomes? Head and tail. For the second toss, number of possible outcomes 2. For the third toss, number of possible outcomes is 2. So by FPC, this is M, this is N, this is P. So by FPC, number of possible outcomes, 2 into 2 into 2 equals to 2 cube. So how many outcomes we are getting? We are getting 8 outcomes. Like a die is thrown 2 times. Find number of possible outcomes. Die. If we toss a die, how many outcomes? 1, 2, 3, 4, 5, 6. So total number of 6 outcomes. So look, number of possible outcomes for first toss equals to, or first thrown equals to 6. What are the 6 outcomes? Phase 1 or phase 2 or phase 3 or 4 or 5 or 6. number of possible outcomes for second toss equals to 6. So number of outcomes by FPC for 2 toss equals to 6 into 6, 6 square. Look, for 1 toss it is 6 to the power 1. For 2 tosses, 6 to the power 2. For 3 tosses, 6 to the power 3. 6 to the power 3. In how many ways? In how many ways? Result of 3 football matches can be predicted. In how many ways result of 3 football matches can be predicted? You know, result of a football match. Is result of a football match may be of either win or loss or draw. So how many possible outcomes for a single match? 3 outcomes: win, loss and draw. So result of first match, the result of a match may be either win or loss or draw. Therefore, this is result of first match. The result of first match equals to can be predicted in 3 ways. The result of second match can be predicted in 3 ways. Not either win or loss, but there is case also, draw. You know, the result of third match can be predicted in 3 ways. So by FPC, number of possible prediction, 3 into 3 into 3, 3 to the power 3. So 27. Now number 4. In how many ways 5 letters can be posted in 3 letter boxes? 3 letter boxes. So L1, L2, L3, L4, L5. 5 letters and 3 boxes. So first letter can be posted in how many ways? Look, 3 ways. It can be posted in box 1, it can be or in 2 or in 3. So first letter, the first letter can be posted in 3 ways. The second letter can be posted in 3 ways. Third, in 3 ways. Fourth, in 3 ways. Fifth, in 3 ways. 3 ways. Therefore, by APC, total number of ways, possible ways, 3 into 3 into 3 into 3 into 3. So 3 to the power 5 ways. 3 to the power 5 ways. Do not write that 5 to the power 3. So 3 to the power 5 ways. How many 4-digit number can be formed from the digit 1, 2, 3, 4, 5, 6. Number 1, repetition is not allowed. Number 2, repetition is allowed. Repetition is allowed. Fundamental principle of counting. So, how many 4 digits number? So, 4 digits number. So, look, there are 4 places. This is unit, this is 10, this is 100, this is 1000. Now, look, 1000 place can be filled by, we are considering 1. Repetition is not allowed, not permissible. So, if repetition is not permissible, 1000 place can be filled by either 1 or 2 or 3. So, it is by 6 ways. Now, then 100 place can be filled by 5 ways. Because repetition is not allowed. If we use 1 to 1000 place, then it is not used in 100 place. Then it is in 4 ways and it is in 3 ways. So by APC, so 6 into 5 into 4 into 3. So 30 into 12. So 360. You can also solve this problem by using permutation. But we are using only fundamental principle of counting. Fundamental principle of counting. So look, repetition is not allowed. So 1000 place can be filled by any one of the 6 digits. 100 place, 1 digit is already used. So 5 ways, then 4 ways, then 3 ways. This is 1. Now repetition is allowed. Suppose there are 2 numbers, 1 and 2. Without repetition, we can form 2, 1 and 1, 2. How many? 2. But repetition is allowed. Then 1, 1 is and 2, 2. They are included. Solution. Here repetition is allowed. So 1000 place, then 100, 10 and this is unit. This can be filled by 1, 2, 3, 4, 5, 6 ways. 100 place can be filled by 6 ways. This is difference because in this place we can use the number used in 1000 place because repetition is allowed. Look, 1, 2, 3, 4, 5, 6. So 6 ways. 100 place is also filled by 6 ways because we can use repetition. So this is 10 6, this is 6. So number of possible ways, 6 into 6 into 6 into 6. So 6 to the power 4. So repetition allowed, not allowed. So this one is possible answer. Now listen. How many 4-digit number can be formed by using? You write a problem. How many 4-digit number can be formed by using 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. So in how many ways 4-digit number can be formed from the digits 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5. So look, number 1, repetition not allowed. Now look, here 0 is present. So 1000 place cannot be filled by 0 because if starts with 0, then it is not of, suppose 0, 1, 2, this is not of 3 figure, this is 2 figure. So if 0 is present, look, 1000 place can be filled by 1, 2, 3, 4, 5. How many ways? 5 ways. 5 ways. Now then 100 place, here you can use 0. So 1000 place can be filled by 0 or any one of 4 because 1 is already used. So 1000 place can be filled by 5 ways. Now 10 place can be filled by 4 ways and this is 3 ways. So why it is 5 ways? Because 0 is not permitted to fill the 1000 place. Because if you use 0 in first place, then it is not of 4 significant digit number. So it is 5, 5, 4, 4. So number of possible ways. Possible ways. 5 into 5 into 4 into 3. So 100. So 25 into 4. 100, 300. 300 ways. When repetition is not allowed. Good. Look, when repetition is allowed. So when repetition is allowed, 1000 place can be filled by 5 ways. 0 cannot be used. Now 100 place, 1, 2, 3, 4, 5, 6. This is 6 ways. Because here 0 and repeated number are permitted to occupy this 100 place. And this is also 6 ways, this is also 6 ways. So number of possible ways. Possible ways. 5 into 6 into 6 into 6. So 30 into 36. 1080. So these are possible cases. So through this video we have discussed basic concept of permutation and combination. What is difference between permutation and combination? Then fundamental principle of counting, then application of it. So thank you.